All right, D. Smith is back. I'm hoping this works this time. It looks like I'm recording both the screen and you can actually see my face. I like that I'm in a little square in the top right corner. And I'm in Mr. Regan's office right now. And actually that poster right there is one that I added to his collection. It's from one of my favorite movies of all time, Good Will Hunting. If you've never seen Good Will Hunting, it's incredible. There is a little bit of language, but just forewarning you, it's phenomenal. So check it out. This video is going to be about two concepts, both of vital importance. Obviously, I wouldn't waste your time, but this is going to be really the building blocks that are going to help us build the unit circle tomorrow. So today in class, we learned what a radian is. We learned what a radian is and how there's actually more than one way we can measure rotation. Degrees is one way, we're used to that, 360 degrees in a circle. But then we learned how a radian is connected to the radius and how that there are 2 pi radians around a circle. Okay, that's what we're going to look at down here. Maybe we start there. Yeah, let's start there. Let's talk about radians. So we're looking at a rotation. And if you remember with our angles, we always start kind of right here, flat. So imagine if you're starting on that flat line and you don't rotate anywhere. Well, that's 0 radians, right? If you don't rotate, you got nothing. What did we say was a full spin? A full spin was, so that would mean you start here, you go all the way around and come back to here. So this point right here can represent 0 or it can represent 2 pi, which will be a full spin. So now that we know that, we can literally find all these other ones as long as we know that a full spin is 2 pi. So I hope you don't feel like you have to memorize every single one, but watch how simple math can save us. If a full spin is 2 pi, what would just be a half rotation be? Well, half of 2 pi is 1 pi. So half of a rotation would be pi. What about if we did half of that and stopped there? We all know that that's 90 degrees. We know that in degrees because we've been doing that since, I don't know, 6th grade, 5th grade. But what is it in radians? Well, it's half of 180, so it's half of pi. We would write that as this, half pi. You'll often hear it said as pi over 2. And then what about here? 1.5 spins to this line right there. How many radians is that? Well, if this is 0, and then this is 1/2 pi, and this is 1 pi, this must be 1.5. How would we write 1.5 as a fraction? 3 over 2. So these are the main 4 quadrants that you really need to know. To help memorize the radians around the unit circle, you need to know these 4 kind of anchors, right? The 4 quadrants. Because here's the cool thing. These 3 are all going to be between 0 and 1/2. It's got to fit in there. These 3 are all going to be between 1/2 and 1. These 3 down here in the bottom left quadrant are all going to be between 1 and 1.5. And last but not least, these 3 have to fit between 1.5 and 2. So, what was the pattern? We looked at radians a little bit. Let's make our way around the circle. This is 30 degrees. That's the degrees. This is that's horrible. This is 45 degrees. This is 60 degrees. And this, as we know, is 90 degrees. So what is the radian measures that are associated with 30, 45, and 60? The radian measures associated with 30 degrees, get this. How many degrees is pi? We talked about that today in class. Pi is equal to 180 degrees. So if pi is equal to 180 degrees, and this is worth 30 degrees, 180 to 30, that's divided by 6, right? So what would be pi divided by 6? Guess what? You don't have to do that math. It's just pi divided by 6. It's a fraction, pi over 6. 1/6 pi. Okay, what about 180 to 45? How many times can 45 go into 180? 45, 90, 135, 180. It goes in 4 times. So this is just being divided by 4. So we do the same thing for the radians because we know that pi radians is the same as 180. So let's divide that by 4. And what do we get? Voila, pi over 4. Try to pause the video and do the same thing for 60. 60 degrees is kind of what fraction out of 180? How many times can 60 go into 180? It can go in 3 times, right? So 60 is divided by 3. It's about 1/3 of 180. So what is 60 degrees in radians? Pi over 3, 1/3. Let's check. I'm going to leave that there because that's important. Let's check and see, which, by the way, means that 2 pi would be equal to 360. Like, those are markers that you want to just have in your mind. So what do we think? Is 1/6, 1/4, and 1/3, is that less than 1/2? Yes, it is. So it's perfect. It counts up. 1/6, 1/4, 1/3. So then we keep going around the circle. This would be 90. Well, here, what we need to do is divide all these in half, right? This is 90 and this is 180. What's right in between 90 and 180? I'll go ahead and spoil it for you. It's 135. What's right in between 180 and 270? I'll go ahead and spoil it for you. It's 225. What's right in between 270 and 360? I'll spoil it for you. It's 315. 270 to, here, let's do this. 90 to 135. That's adding 45. 135 to 180, that's adding 45. So what I'm about to show you, is we're going to pause here and I'm going to jump up to the special right triangles, is that the unit circle is built off of these special right triangles. That's going to develop in Tuesday's lesson, but I have 6 minutes left here to try to give you a head start, okay? Because it goes, notice, 30 degrees. What do you know? I could form a triangle right there. Oh, shoot. 45 degrees. I could form a triangle right there. 60 degrees. Okay. Over here, we've got another up 45. So that would probably be just up 30. So this one's 120. 30, 45, 60. That would be 150. Okay. So we're going to keep building radians around the unit circle. We're going to keep building these patterns. I just wanted you to see that quadrant 1, if you can master quadrant 1, that should be your goal here these first couple days, because literally it just connects to all the other quadrants. If you're good at recognizing patterns, then you're going to crush the unit circle. If you have a good memory, you're going to crush the unit circle, but for a different reason. There's a lot, everybody has an avenue to this. Don't feel like it's all memorization. It's not. It's a lot of pattern recognition and really understanding quadrant 1. And then understanding this, special right triangles. Okay? Do you remember, how do I want to do this? Yeah, let's go review of right triangles. It's a little different than I wanted to do it, but we'll roll with it. What is so we've got a 30, 60, 90 triangle. That's one of them. And then we've got a 45, 45, 90. Okay, those are the two special, yeah, that's what I'm going to do. I'm just going to ditch this one because it's just 30, 60, but it's backwards. It's 60, 30, 90, it's the same. So we're going to look at these two because I don't want you to feel like there's 3. There's really only 2 special right triangles. Why are they special? They've got some really core relationships here. And I'm going to show them to you in 4 minutes. 30, 60, 90 triangle. If it looks like this, let's say that this is the, here, let's make it look a little bit more. It'll be, one will be shorter and one will be a lot longer. The reason we do that is because obviously this is the smaller of the two. That's the 30. This one's a little bigger. That's the 60. And then we've got the 90. Check this out. if you know the smallest leg, then you automatically know that the hypotenuse is double, and you automatically know that the longer leg is whatever the smaller leg is times the square root of 3. Take a look at that. That is something that you did in geometry a lot, but some of you, it's been a minute since you've been in geometry, but we're gonna use this concept of square root of 3 is going to be a very important number tomorrow, and the square root of 2 is going to be an important number tomorrow. So for a right triangle, if we know the small leg, we can use the small leg to work up to the hypotenuse and to work up to the longer leg. If we were given the longer leg, we'd have to work back to the small leg and then back to the hypotenuse. Like the key, you can go from any side. Okay, for example, I'm not going to do this for all of them, but if I knew this is a 30, 60, 90, let's say 60, 30, and I said that the small side was 6, that would mean that the hypotenuse is 2 times 6, so 12, and it would mean that the longer side is 6 times root 3, so 6 times root 3. That's literally, if you know the small leg, you can solve it out. So that is a 30, 60, 90. Very special. Only works, this relationship only works for 30, 60s. 45, 45, 90s have their own relationship. They're isosceles, so this side 45, this side 45, which means that these sides are equal, right? So what is the relationship between them? Well, we know they're equal, so if this is x, this is x. It's kind of nice. And then here's the special thing. You can work up to the hypotenuse by doing x times the square root of 2. That is a special relationship between those. Sorry, I'm OCD getting the blue in. Those are the two special relationships in your right triangle. So, moment of truth, and you can rewatch this video if you need to. What happens if our triangle has a hypotenuse of 1? AKA, come on, AKA if it's a unit circle. I hope you just made I hope maybe you just had an aha moment right there. If it's a unit circle, check this out. If we draw our triangle, whoops, and it's a 60, 30 triangle with a hypotenuse of 1, how would I work back to the small side? If I know my hypotenuse, wouldn't I just divide by 2 to get my small side? So the small side is 1/2. And now that I know the small side is 1/2, how would I jump to the longer side? I do the small side times root 3. So what is 1/2 times root 3? That's the square root of 3 over 2. These numbers right here, oh my goodness, you got to memorize them. You just got to memorize them. You don't even have to. You're going to see them like crazy tomorrow. And then last one, what if a 45, 45, 90 has a hypotenuse of 1? So we know this is 45, this is 45, and this is 1. How would we work backwards to get the small sides? It's small side times root 2. So to work backwards from 1, we would have to do 1 divided by root 2, which is a weird number. So we do some rationalization, and you get the square root of 2 over 2. That right there is going to become one of your best friends. So I have 30 seconds to wrap this up. You hung tough. We are going to use the idea of radians all the way around the circle. You're going to be able to know that this is 3 pi over 4. You're going to be able to know that this is 5 pi over 6, that this is 2 pi over 3. We're going to talk about that, go all the way around the circle. But the key is this: your special right triangles. So I encourage you to remember these connections, store them away, and come tomorrow ready to get after it. Good luck, gang. Look up Good Will Hunting, see if it's still on Netflix. You guys are crushing it. Send me a message if you're feeling nervous. I want you to feel successful. Have a great one. Bye-bye.